So let's take a look at a few more exponential equations. And this time we're going to see if we can answer or solve these equations using logarithms. Let's go ahead and do that. So here we have 5 to the negative x minus 10 is equal to 17 to the negative 4x. Okay, well, the first thing we should always do when you see one of these is to see if you can find a common base. If you can find a common base, that will be the way to go. Because then all you have to do is find the common base and then compare each of the exponents to each other and solve it that way, and it'll be much faster. But unfortunately, with this one, since both of these numbers are prime, we are not going to find a common base. Okay, they don't both have to be prime to not be able to find a common base, but that's a surefire way to guarantee they don't have a common base. So we have to see if we can use a different method. So let's see what happens if we take the log of both sides of the equation. So let's do that. So we have log of uh, 5 to the negative x minus 10 should be equal to log of 17 to the negative 4x. And now what we can do is we can use the the power rule to rewrite this. So we can actually rewrite this as negative x minus 10 times log 5. Okay, and we can rewrite the other side as negative 4x times log 17. So let's go ahead and distribute this log 5 over here. So we'll have negative, uh, sorry, negative x times log 5 minus 10 log 5. All right. And that'll be equal to negative 4x log 17. Okay, so let's see if we can isolate all of the x's on one side. So we can go ahead and add 4x log 17. Okay, and we could also add 10 log 5. And that'll cancel a few things out. And now we're going to end up with negative x log 5 plus 4x log 17. And this is going to be equal to 10 log 5. Okay? So now, if we look over here, we'll notice that we can pull an x out of this side of the equation. So we can rewrite this as x times negative log 5 plus 4 log 17, and that'll be equal to 10 log 5. Okay? So we can then divide both sides of the equation by negative log 5 plus 4 log 17. Okay? And these will cancel, and we'll have x is equal to 10 log 5 over, we can rewrite this bottom one to switch the order so it looks nicer if we want. We can also leave it alone. We'll go ahead and leave it alone. Negative log 5 plus 4 log 17. So there we go. X is equal to 10 log 5 over negative log 5 plus 4 log 17. And if you plug that into you can plug that into the calculator if you want to, but I believe your homework wants you to put it in like this, because this is the most exact way to answer this this equation, okay? Let's take a look at this one. Here we have 17 to the negative 5x is equal to 6 to the x plus 3. Okay, well they're not both prime numbers this time, but since 17 is a prime number, you're not going to be able to find a common base at all for these. Okay, um, so yeah, so I guess that means since we're not able to find a common base, we have to rewrite this using log. So let's take the log of both sides. So log of 17 to the negative 5x is equal to log 6 to the x plus 3. And using our power rule, we can rewrite both sides. So we can have negative 5x log 17. That'll be equal to x plus 3 times log 6. Okay, let's distribute this log 6 to the x plus 3. So we'll have negative 5x times log 17 is equal to x log 6 plus 3 log 6. Okay, let's see if we can get all of our x's on one side. All right, so let's go ahead and take x log 6 away. Okay, and we'll end up with negative 5x log 17 minus x log 6, and that's going to be equal to 3 log 6. So let's see if we can just pull an x out over here. They both have an x in common, so we'll have x times negative 5 log 17 minus log 6 is equal to 3 log 6. So we divide both sides by negative 5 log 17 minus log 6. And we end up, after canceling, we get that x is equal to 3 log 6 divided by negative 5 log 17 minus log 6. So there you go. These are a little bit tedious. They take a little bit of time to write out, but this is a very good way to find the exact value of x. And you can plug this into a calculator and find the exact value of x here. It's probably going to be some irrational number, or at least some mess of a number. However, this is a good way to find the exact value.